In 2017, astronomers spotted something that defied everything they thought they knew. A strange silent object suddenly appeared in our solar system, moving faster than anything they'd ever seen. It wasn't orbiting the sun, it was just passing through. They named it Oumuamua, and to this day, no one really knows what it was. Was it a cigar-shaped rock, a frozen shard of interstellar ice, or something even more artificial? Then, in 2019, it happened again. A second interstellar visitor, Comet Borisov, confirmed that Oumuamua wasn't a fluke. Something was out there, sending fragments, messengers, or maybe just debris our way. Now, in 2025, it's happening again, but this time, we're ready. On July the 1st, a new object lit up the near-Earth object confirmation page. Astronomers gave it a placeholder name, a 11PEI3Z. It didn't look like much at first, just a faint dot on a telescope image, but within hours, something about its motion felt off. And once astronomers started running calculations, the results were jaw-dropping. This object wasn't bound to the sun, its orbit was hyperbolic. It was on a one-way ticket through our solar system, just like Oumuamua and Borisov before it, but this one's different, faster, weirder, and maybe bigger than both of them combined. To understand how wild this is, you need to know a little space physics. For something to be considered interstellar, it has to be moving faster than 42 kilometers per second. That's the escape velocity of the sun, the speed needed to break free from its gravitational grip forever. A 11PE3Z is coming in at 66 kilometers per second. That's not just fast, that's insane. Its orbital eccentricity is about 6, the highest ever recorded for any object in our solar system. This thing isn't just passing through. It's speeding through on one of the most extreme trajectories we've ever seen. Unlike with Oumuamua, which we noticed 5 days after it passed Earth, this time we caught it in advance, and not long after the initial sighting, astronomers began combing through past telescope data. Sure enough, they found it in images taken on June the 25th by the Atlas survey. With those extra data points, they confirmed what many already suspected. A 11PEI3Z is interstellar. It has now been officially cataloged by the Minor Planet Center under the nickname 3 Atlas Hour. Third confirmed interstellar object. According to its current path, 3 Atlas will reach its closest point to the Sun on October the 27th, 2025, at about 1.4 astronomical units, just a bit farther than Earth's orbit, but unfortunately Earth will be on the opposite side of the Sun at that moment. The object's closest approach to Earth will happen later, on December the 17th, when it will be about 2.4 astronomical units away. That's not exactly close, but it's near enough for telescopes to monitor it carefully. After that, it continues its journey outwards, skimming past Jupiter's orbit by March 2026, and then off into the darkness once again. So what exactly is it? Based on its brightness, astronomers estimate that if the object has average reflectivity, it could be about 20 kilometers wide. That would make it significantly larger than Oumuamua and even bigger than Borisov. But here's where things get tricky. That estimate assumes it's an average rock. If it's especially shiny, it might be much smaller. Or if it's venting gas like a comet, it could appear brighter than it actually is. That's what happened with Oumuamua. It didn't have a visible tail, but it did show signs of acceleration that couldn't be explained by gravity alone. It was as if something was pushing it, gently nudging it off course. Some said it was ice evaporating, others weren't so sure. And now all eyes are on a 11PE3Z. Because if it starts accelerating in weird ways, just like Oumuamua did, it could open a whole new chapter in the search for answers. Non-gravitational acceleration can happen when gas vents from a surface, but in more exotic theories, it could be a sign of artificial propulsion. Yes, that sounds like science fiction, but it's a real scientific conversation. To get to the bottom of it, astronomers are turning to our most powerful tool, the James Webb Space Telescope. With its incredible infrared capabilities, Webb could detect heat signatures from the object, telling us how warm it is, how reflective it is, maybe even revealing its shape. Is it tumbling, spinning? Is it an icy body, or a rocky one? Or is it something we've never seen before? Another strange clue is its orbital tilt, an almost perfect 175 degrees. That means it's coming in nearly upside down relative to the rest of the solar system. That alone almost guarantees it didn't originate here. Its path suggests it was flung from the Milky Way's stellar disk, a vast plane where most of the stars in our galaxy reside, and that opens up a tantalizing possibility. If we can trace its exact direction and speed, we might be able to figure out which star it came from. Imagine that, a rock, or perhaps something more from another solar system drifting for millions of years through interstellar space, now passing through ours, a cosmic message in a bottle. But this discovery doesn't exist in isolation. In fact, we're just entering a golden age of discovery thanks to the Vera C. Rubin Observatory. Named after Vera Rubin, the astronomer who helped uncover dark matter, the observatory has one job: scan the sky again and again every few nights for 10 straight years. This project, called the Legacy Survey of Space and Time, is already changing the game.